that are used in our to demonstrate the strategy and to demonstrate the materials that would be used to work the various activities. So we're going to get started with that. Give me one moment to get that pulled up. Okay. You can unmute or raise your hand and just tell me if you can see my screen.
Yes.
You guys see my screen?
Yes.
Okay, let me move this over. Okay, and I'm gonna see if I can, someone nod, can you see my math screen?
See, that was exactly the situation.
I see where it says math level 1.
Can everyone see my screen?
Yes. Can you hear me?
Tanya, can you see my screen?
Yes. Can you hear me?
You'll have to unmute. Okay. Tanya, can you see my screen?
Yes.
Absolute end goal for comprehension.
Can you hear me?
Okay, and I'm gonna look. Let's see.
Take in information, comprehend it, explain it to someone in a way that is clear, that is continuous. The example that I like to give is, I am the worst person. I have never got my life for directions. I could get lost in
All right. Can someone unmute and tell me if they can see my screen?
I'm unmuted. Can you hear me?
And I would manage to get away to the grocery store for once without having to call my girlfriend.
Hello.
So when you look for that, a lot of times it might be a vocabulary issue. Just
Okay, thank you. I'm sorry, guys, and that's just, this will become more streamlined. It's just that I wanted to make sure that everyone is able to see it. Thank you. Sorry about the repeats. Wonderful. Okay, hold on. And then some people are. Let's see. And some of you, yeah, you can. I'm going to make it so you should be able to unmute yourself now. And let me just go ahead and have everyone introduce themselves too, and make sure that you're able to unmute and mute so that I can hear you. All right, is it Cece? Sorry, Cece. Okay, and if some of you may be muted because you don't want to.
Denise, can you hear me?
That's fine.
I got a little squirrely going.
Tanya, are you able to unmute?
Yeah, I'm unmuted. Can you hear me?
Okay, now, sorry guys. All right, now let me I've made an adjustment here. Sorry, we will get the kinks out of this, I promise. Okay, Tanya, can you
Yes.
see? Wonderful, now we got it. I am so
okay. I kept telling you I could see your screen, but you couldn't hear.
No, here's that's very embarrassing. I'm so sorry, y'all.
No, that's okay.
Okay, and if I could have you all introduce yourself. Cece? Christy?
I'm sorry, I'm here. Hi.
Hey, Cece. And
This is a bit laggy.
am I pronouncing your name correctly?
Yeah,
Okay, awesome, thank you, Cece. Christy? Are you there? Christy, are you there? Okay, let's see. Nancy.
How's everyone?
Hey, Nancy. Good. How are you?
Good, thank you.
Good. And Jay. I just see a J there. Do you want to introduce yourself? Okay, no worries. Okay, so we'll get started. And please feel free to unmute because I'm going to make it so that I can see as much of my screen as possible. So feel free to unmute and ask questions as we go, all right? All right, here we go. So we're treating math level 1 as an introduction into the numbers 0 to 5 and their concepts. So, and I'm sorry, I'm gonna have to see you guys. It's something hard to. The math and the numbers and their concepts. So we start with just introducing them, and as we talked about before, our language, or math is a language. And so we have symbols and we have concepts and we use it to communicate. Think about the last time you told someone, hey, I'll take half of that. They just went and picked a bunch of fresh blueberries. And I'm trying to think of something that's really nice and that's not the virus. So someone goes to pick some blueberries and you tell them, oh, those look great. I'll buy half of them from you. So we're always using math in our communication. Okay, so for big picture here, again, math is a language. And so the way we address math is, and the way we use math is to talk about it in the parts of something and then the whole thing. So picture pieces of a pie and then the whole pie, or half of the blueberries and then the whole thing of blueberries that's going to be divided up because you've asked for half of them. So it's always all about parts and whole. So and it's the way that we also address comprehension, is that we're always integrating imagery. So you're creating an image, concepts in your brain, creating that movie in your head. You can see a movie, it's not very interesting, but in that movie, you've got the blueberries and you're dividing them into half, or you have the big pile of apples on the ground and you're gonna put them into baskets, and you have 3 baskets. So a few apples in each basket. So you can see that movie in your brain, and it's dealing with math. So we use our imagery and we attach it to numerical symbols, and because we want to build the symbol and its concept and that whole representation, we want to build it into a language that the student is fluent in, and so that they can quantify it, put numbers on it. We're going to leave to go to church in 2 hours and 25 minutes. We quantify it, we give them a quantity. Again, communication and problem solving. I'll take half of those blueberries, please. And then problem solving, well, if you take a third of the blueberries, we have 21 blueberries, and I don't know why I'm hooked on blueberries today. If we have 21 blueberries and Sally is going to take a third of them, how many blueberries is that going to leave for John and then Peter to have? So it's problem solving. And so if we address it like that and think about it as learning foundationally, just like we learn sight words, the, and, of, and then we also learn that letters represent certain sounds, so that k and can is a symbol. The C, the A, and the N is a group of symbols that represents that you are able to do something, or you've got some tomatoes in a metal container. Is all that making sense so far? And feel free to unmute, because it's really, yeah, perfect. Thank you, Tanya. I know you're okay, let me see. I'm sorry, and I'm actually responding to someone via text concerning our math room. Okay, so all that's making sense is how we approach math, and it really takes a lot of that, because honestly, I was not a math major. I was a language and communications major. So math wasn't, I had enough just to get, to get through higher education. And I took the minimum number of math. I love math now. I love to use it. And I find it, because of this approach, is seeing it as a language, has just been very helpful. It's just it's taken the mystery out of it. Okay, does that make sense so far? All right, I'm looking at my chat box open, making sure I've got everybody. So here, and this is all looks very complex. And by the way, you guys are all going to get copies of this digital file here, this foundation of math, and how and because this sets the stage, you'll get a digital copy of this. I will email it to you. Just make sure that I have your email, and we'll make sure that happens before the end of this session. So we look here. We have just basically imaging the numbers, seeing what 0 to 10 and over 10, what each of those numbers represents. We compare the numbers, we add them, and we're talking about whole numbers here. We're not getting into negatives yet or anything like that, and we're not getting into parts quite yet. So that's what we're talking about, the whole number. So we're working with, we're not working with fractions and decimals right now. So we're working with big numbers, or numbers that are whole and not subdivided into decimals, fractions. But we will start dividing whole numbers early on. You've got 2 apples, you've got 2 people, each person gets 1 apple. Start dividing them up early on, adding, subtracting, and then we always want to work a word problem, because if math is a language, we need to tell a story with that language. We need to problem solve with that language. We need to communicate with that language. So we're always looking at word problems, and in those word problems, in this first, see, these are the various stages. So within these stages, right, within these stages, whatever number range we're working in, whatever type of numbers we're working, we're always going to, and in whatever computation, adding or subtraction, whatever we're doing, those numbers, we always want to work it within a word problem. Also, while we're working these numbers that I'm pointing to, 0 to 10, and adding and subtracting, we're always comparing them, manipulating them, showing how we can divide them up, or showing how we can break it into parts. So that's always going to happen at each stage, okay? So just as a broad overview, a broad brush, multiplication, we start bringing in the second phase, and we start introducing place value. When we get to 10 and base 10, it's introduced here, but we go more into it here. We're working multiplication, division, again, multiplication and division always together. Okay? So we work all of that, then we start getting into more into place value, carrying, borrowing, all of that. So understanding the concept and then applying the concept to computation. And so Sally has 25 tickets to the show, and John has 12. That's a story. We could picture, and we can talk about what kind of concert they're going to. What colors hair does John have? How tall is he? So, and then our computation is where we actually solve it. So we're just going to add that 2 numbers of tickets that we saw in our story. Okay, that's a detail from our story that we want to recall. I'm going to put those numbers together. And so for our computation, fancy word, our computation for that, to solve that problem, is just adding. Okay, so we're always working working computation into it, and we'll go into that in just a minute. So then here we go more into multiplication, division, complex. Then we go into more complex with fractions, decimals, and percentages. And all of that deals with money, with the clock. 15 minutes is not 0.15, 15 minutes is 0.25, because it's a fourth. 0.25 is a fourth, right? A nickel is 25 cents. So when we're talking about fractions and decimals and money and all of that, it's just little things that we learn. And so we know that 15 minutes is actually 0.25 or 25% of an hour. It's a fourth of an hour. Okay. Now, all this making sense so far? Here's the deal. All of this, and I do have my chat box open if someone doesn't want to unmute but wants to chat me, I've got it open right here. So I'm actually looking at it, feel free. And if something's not clear or something's not making sense, you can absolutely tell me. Okay, so once all of these foundations are solid, and I should say, all of these foundations, these phases have to be solid in order to do anything with it, like algebra or geometry. All of this has to be solid. This all has to be there. Otherwise, 6th grade math, 5th grade math, or when they start bringing in algebra and all that, that's going to be that Russian 300 level class at the university that I'd be sitting in. I'm going to mute. I hear some talking in the background, so I'm just going to mute just so that. Okay, guys, just make sure that you're muted. Make sure you're muted so that We're not here in conversation for your privacy, okay? So all of this, does this make sense? So if your student is struggling in 4th or 5th grade math, it's because these things aren't solid. So we can't go into all of the higher levels until this is all solid. Does this make sense to everyone? Does someone want to share where the breakdown is or where some of the struggles are that you see with your student? And whether is it addition and subtraction? Yes.
This is Nancy, and I'm actually appreciating all your slides. So my son, I have 2 children with autism, and I'm going to speak about my son. He's a 4th grade. In 4th grade, they're teaching him multiplication. He has not even had the foundation. And our problem has been that since he's self-contained, we've had new teachers every year, and they're just moving him forward. So he is just shutting down. He's not getting these foundational steps. So what would you recommend? And then that's not the teacher's fault, but that has been our struggle because obviously the teachers are new and they're in our district, self-contained teachers are not going to content training. So they're just, I guess, skipping through. But what would you suggest for us to request so that, I mean, I understand 4th grade may be working on multiplication, but if my son's not able to do regrouping or addition for regrouping,
Absolutely.
what would you recommend?
And as we go through these slides, and again, I'll share this with you, Nancy, all of this, it's all about, you know, and even if you have to show the teachers what these foundations are, because if he's not getting, if he doesn't have addition and subtraction really solid, and understanding the different types of numbers, prime numbers, even numbers, odd numbers, all of the other things are going to be really tricky. So he's sitting in a 300 level Russian class right now, and he hasn't had the first level of Russian yet. So all of this, and I would shut down too. I absolutely would shut down. So I think with this, the general flow of this, this document that I'm sharing with you all, I think having that is going to demystify what the foundation is and how to work the foundation, because I actually have activities built into this, and you'll get those activities.
Okay, now, and last question. Now, do you suggest a certain curriculum? Because the curriculum that we use is unique learning. And that has not worked for him. But again, it might be that the teachers are not trained well. I don't know.
Okay, and Nancy, I'm sorry, could you repeat the first part? You kind of broke in and out on me.
Oh, I'm sorry.
Okay.
And do you suggest for a certain curriculum? Just because they use unique curriculum, it's not worked for these years. So any suggestions that you can offer would be appreciated.
Yeah, oh, absolutely. And I'm not using any type of particular program. It's just building concepts, right? In the scaffolding of skill building. So you're building concept attachments to symbols, and you're building a firm grasp of the concepts and able to manipulate those concepts and work with them. So I'm going to show you, and we're always going to be developing different ways to work this. So yes, I think hopefully this will be helpful in just kind of showing how, there we are, in showing how to build those concepts, build those skills, because it's all about building the skills, and you approach it in different ways, you know, visual, auditorily, within a story, all of those things are going to be worked into the skill building. So hopefully some of this will hit home, and you're welcome to share what I'm sharing with you and what you'll get, which is this, these slides. You're absolutely welcome to share that with the teachers. And I'm sorry, you were breaking in and out a minute ago, so let me know if you're able to hear me, and let me know if I answered your question sufficiently. Anthony, are you having trouble hearing?
Oh, no, we're done.
Okay.
Well, for all of it, I only had 3 people answer all the questions.
Okay.
How's it going with you?
It's good. Okay, let me.
Denise. I can't hear you anymore. It shows me that you're muted.
There we go. Thank you. I thought
Okay.
I must have clicked it and it didn't take it from me. Thank you, Tanya.
You're welcome.
Thank you, ma'am. Okay, so getting the concept attached to the symbol, so really getting strong on the concept. Then we go into the computation, meaning, and here's what I mean by this. Computation, remember we talked about, are you gonna add? Are you gonna subtract to solve this story problem, this math problem? Are we gonna divide because we've got a bunch of blueberries and we've got 3 different people who want this pile of blueberries, and we're gonna divide it up. So what is it? Is it gonna be division, addition, subtraction? What is our computation? And you gotta be able to put it on paper, right? Or put it in your head. 3 times 2 is 6, right? There's your computation. So we get the concept, so that we know what we're dealing with, and then how we're going to problem solve. What type of computation are you going to use? You can divide, subtract, whatever. And then guess what? And this is like really a general flow, okay? Guess what? You can use the calculator, because none of us here, for example, if we're going to determine what percentage of our monthly income needs to go towards paying for groceries or whatever. Okay, we're trying to just figure out our budget. We want to know what percentage of our monthly income goes to groceries. Do we need to cut down? Do we need to eat out less? Or let's just say it goes to feeding our family. What percentage goes to feeding our family? We know in our brains that we're going to figure out how much we spent, and then if we want a percentage of it, I'm making this way more complicated than it needs to be, but let's just say our monthly income was $2,000, and then I spent a certain amount on food. We know that we are not necessarily going to do this in our brain, is what I'm getting at. I'm sorry. But we do know how we're going to compute it, right? We know how we're going to figure it out. And so we grab a calculator. None of us are going to try to balance our checkbook in our heads. I mean, unless you just round and kind of just estimate. We're going to use a calculator. So early on, it's okay to introduce the concept to the kiddos that a calculator is useful. But it doesn't matter. If you don't have the concepts, if you don't have the computation and know what you're going to do with your calculator, it's of no use, right? It's only a tool. The calculator is not going to, you can't read a word problem to your calculator and it's going to automatically figure out the answer for you. This is a tool, and it's a valuable tool, and it's going to be used. So it's no use pretending like it's taboo. And, and for all of us who were balancing our checkbook, we're going to use it, although we could go and add all those numbers and carry and borrow and all that stuff. We could totally do that, but we're not going to, because it's not efficient. So as soon as we're applying these concepts and the computation we use, when we're applying it to problem solving, we're going to use that calculator for efficiency. So it's okay to introduce that to them. Okay, and does that make sense to everyone, that why I'm even mentioning a calculator? Because, okay, that makes sense. All right. And then also we get to the point where we're estimating, and this kind of works, and these really aren't that linear, they kind of interrelate, but estimation, and then again, check ourselves, so we might look at our checkbook and look down the rows and see what's subtracted, what was put in, etc. And we can kind of come up with a figure in our brain of where we think we are, but then we're going to use that calculator when we need a precise, definitive number. Okay, so that's our general flow. The reason, and all of this is important, guys, and the reason I'm spending so much time on this, and I'm going to follow up by sending you these slides, the reason I'm spending so much time on this is because this sets the stage. This is how we approach math and how we come in, find where the crack in the foundation is and address it. And this is the flow, this is the skill building. So in a progress summary, we're going to know exactly what their proficiency. So we report in our progress summaries for our students, we report where they are, what their proficiency level is in all of this. And that explains why we haven't gone to this yet, because we're still building this. So this shows the flow. If there's not a blueprint, how do you know how much progress you've made on the building? You just know it when you see it? I mean, that's not, people who are paying you to build a house are going to want to know exactly where you are. They want to know where you want to get to, built house, ready to go, versus where you are. Okay, so that's why I'm spending a lot of time on this foundational stuff. Okay, so let's just talk about what's in this packet. Move this over. Okay, so it's going to be a set of slides that we're going to work numerical symbols. Okay, that's just numbers. So instead of working letters, we're working numbers and their concepts. And we're going to focus, since this is setting the stage and setting the foundation, we're going to use numbers 0 to 5 in order to, because let this packet give you the foundation for which you would work 6 through 10 and more. And we'll have more packets available, but this really just sets the stage, so it's just easy numbers for us as the instructor, okay? It gives us easy numbers for us to work with as we're teaching these concepts and the computation and the problem solving and the math stories when we're teaching it to our kid. And then we'll get into higher levels where we have introduction of base 10, some place value, and what we're developing now are some games and some laminated cards that show prime numbers. Anthony had a beautiful idea with the color coding, prime numbers versus even and odd numbers versus numbers that are divisible by 5, so and numbers that are divisible by 3, all of that good stuff. Okay, so we're going to explore from the very beginning parts and wholes, like parts, the whole thing, and then its parts, and then with 0 to 5, we're going to really focus on addition and subtraction. However, even when you're just doing 0 to 5 and you're just working the concepts, and just think about it, whether you're 4 years old or 15 years old or 30 years old, trying to get a grasp of the language of math, this is our starting place. So we're going to start with addition and subtraction, but we are going to go into in an informal kind of an organic introduction to multiplication and addition. And again, we're not ever going to discuss them separately. Neither, and same thing with addition and math. I mean, addition and subtraction. They're interrelated. If you've got one, you've got the other. Okay. And learning, and I'm going to say this, and I hope I'm not making any teachers mad or anything, but learning and memorizing the multiplication table is all good and well. But if 3 times 5, if I know a bunch of students who've got 3 times 5, 12 times 6, 9 times 4, like they've got it. They've got it. Okay. When they see those numbers, 9 times 6 on a card, they've got it. But what do you do with that? How do you even use it? Why is it even important to know that 9 times 6 is 54? And did you know that 54 divided by 9 is 6? And 54 divided by 6 is 9? You know, so do you know the concepts behind it? That's the only reason. And we only know multiplication tables. It's almost like a calculator. It's just a tool. And we just learn it because it's a shortcut. But I'm more concerned if the kid knows that 9 times 6, because they have a good concept of 9 and they have a good concept of 6. They know those numbers. They've worked with them. They know about the amount that they are. 9 is closer to 10 than it is to 5, right? It's almost 10. 6 is just a little bit bigger than 5, right? I'm more concerned is, can they estimate it? And that's where that estimation comes in. Can they estimate what 9 times 6 would be? I mean, and it's great that they know this. I'm not saying knowing your multiplication table is a bad thing, but if it's hollow, if it has no meaning behind it, it really serves no purpose. Is that making sense? Does anyone want to disagree? I'm always open for discussion.
Hey, I have a question.
Yes.
Okay, and I know this may be different than some other kids with Jesslyn.
Sure.
No numbers have a meaning to her.
Gotcha.
They're just numbers. That's what I have been finding out since we have started homeschooling. They're just numbers. They have no meaning, and I don't understand how to make them have a meaning.
You got it. And that's the beauty of it, Tanya, and is that we're going to start with 0 to 5, and we're going to create meaning. Okay. And we can't start with 27 because then we're getting into place value. You've got 2 sets of 10, and then you've got some ones. It's just, we need to make sure that those numbers do have meaning. And we're going to, I think I have it in this next slide, Tanya, and if I make sure that I address this with you, and address this in general, that they have to have meaning, and we use a process to get to that.
Okay.
We want to we hand them the stimulus, okay? Or we hand them the manipulative or the thing. So we hand them a picture, or we show them 6 apples, right? And that's the symbol 6. So all of that has to be attached, and you show it to them, and then all of a sudden they don't need to see the pile of apples every time they picture 6, right? There in their head, they're going to picture 6 of something: 6 cars, 6 boats, 6 bottles of lip gloss or packages of lip gloss or 6 picture frames. I don't know, you know, so it's going to start having meaning, and that's what has to happen. That's that foundation that has to be built. And we're going to give them different ways to grasp that concept. So we give them the stimulus, we give them the picture, then we start going to their imagery they create in their own brain, and then bring back the image, bring back the actual stimulus, bring back the manipulatives, the pictures of the 6 apples or whatever. We bring
Right.
it as needed to reinforce. Does that make sense, Tanya?
Yes.
Okay, so it's building. It's not, you know, understand that that's so many kiddos, they are just numbers. Just like for so many kiddos, and Jessalyn I know is a good, her fluency is awesome. Just for a lot of kids, GLUE or GUM is just a bunch of symbols. It's GUM. But the concept of that could be like what's keeping your teeth in your mouth, or it's what you chew on, you know, that taste has flavor. I mean, so does it make sense now, Tanya? I mean, it's okay that they don't have meaning because we need to build it. It's kind of good to know where we need to start from, right?
Yeah, I feel like I've started over.
I know. I understand. I understand. We have to build them and keep using them, you know, and I know this, I get it. All right, please ask questions. Anyone? Stopping for questions. And so please keep in mind that with comprehension and fluency, right? Because they're all part of language, just as math is a language. You got to keep track. And this, Tanya, here's where all this, you know, this addresses your question too. When do you go on to the next section? I mean, when do we know that that concept has been grasped, that those numbers now have concepts attached to them? We keep track of it, you know, write it down in your notes, and we're going to provide you in these slides with some ways to take notes to track how automatic they are. So just like with fluency, you got to have those letters attached to sounds, and it has to be something that they have grasped independently and automatically. If they're still having to think about how many cars are in a pack of 6 cars, or how many pieces of chalk are in a 6-pack of chalk, you know, it's not automatic yet. If they're still having to, you know, it's not independent and automatic. It's got to be that, and that's when you move on. So that's when you, this should say prompted. So this is the beauty of me being able to without being prompted. Okay, so in other words, you're not having to show them, you're not having to prompt them to image 6 items by handing them a picture of 6 flowers or getting 6 balls of Play-Doh out. You know, once you don't have to prompt them and show them anymore, then they've got it. But when you prompt, that's when you're providing the student with a little help, and that can be with bringing a stimulus in, or you even say, is 6 a whole number, or is it 6 an odd number, an even number? You know, when you have to get down to choice contrast. And this is the kind of data that you're wanting to see, right, in your IEP. So when you ask for data, this is probably what you're looking for. Like, you're looking for that individual skill, whatever that skill is, that's not some skill that's out here in left field, right? Not like you memorized all the numbers that go with pi. You know, I know some kids had to, because they won like a contest, is 3 point, and remembering all the numbers. So, I mean, it's a skill, but is it relative to the actual end goal of having a strong concept of numbers and being able to work numbers and go into higher level math with those number of concepts and solve everyday problems and even some tricky algebraic, you know, problems. So the notes should indicate which applicable and important and foundational skills are being worked on, and where are they? Where is their independence and automaticity? They get it accurate and fast. What's their level with that individual skill? And if it's not where we'd like it to be, our session note should also indicate what we're going to try next. Well, okay, well, let's try building that concept by doing this. So be an example of the kind of session notes and the kind of data you expect from teachers, from whomever is in charge of your child, of building skills, you know, important skills and abilities. Is that making sense? Oh, a quiet group. I feel y'all are just making me seem even louder than I am because y'all are so quiet. But I mean, have any of you, do any of you have any, any examples of data, or, do you see that you're getting data that's letting you know exactly where the struggle is, or exactly what's being worked on and how proficient your child is?
No, getting none.
Okay.
We wasn't getting anything.
Okay. Yeah, this is not a leading question. I'm not trying to set anyone up. I mean, I honestly am asking because, sometimes there are teachers out there that are, that are giving good data, and we want to see examples of that, because that just lets you know where your child is, where the breakdown is. And I think I mentioned before, I mentioned last week, you parents, Tanya, you just said, she doesn't have the grasp of what a number is. Just a squiggly line, some straight lines and some curly lines, or some curved lines on a page. So yeah, absolutely. So be the example over this break of the kind of session notes you want for your child, and what kind of levels of proficiency you're going to report for those specific skills. Are they having to be, is it independent? No prompts needed, they've got it, independent and automatic? Or are you having to give them several prompts, showing them a picture of 6 apples, telling them, are you having to help them get this? Or are you having to, because being able, it's like, like a classwork assignment, it's great on a finished product, even in your, as a finished product, even in your child's handwriting. But if you were the one that had to basically do the worksheet, what value does that have? Or if you had to work the problems, even though it's in your child's handwriting, what value does that have? What does that show about their mastery of the skill that needs to, because we're all developing skills. I mean, that's what they all, you have to develop this skill and this skill and this skill and this skill to get to some end goal. And yeah. Okay. Let me go over here now. Let's see. Okay. So, did I skip one? I wanted to make sure I talked about, I think I already did. Maybe I already addressed it. Okay. Anyway, so with here is just simply, right? There's that phase 1 that we've already looked at within the general scaffolding of skill development, right? So this is this. Does that make sense? So now we're going to look at it here. But since this little introductory unit, we're just dealing with 0 to 5 for you and for your student. Even if your student is solid with numbers up to 10 and 15 and 20 and 30 and 40, and meaning like they got a good sense of it, where they are in the number line and all of that, where, let's just start with this to give you a sense of how we approach math as a language. So our focus here in this particular set of slides is 0 to 5, okay? So any of this, I've marked off the 10 and put a 5, because this is what we're dealing with in this particular packet. Okay, so we're going to make sure we have an image to go with each number, a concept up to 5, 0 to 5. We're going to compare numbers 0 to 5. Is 4 greater than 3 or less than 3? Would you rather have $4 or $2? Okay, and adding and subtracting, always together, but we're just going to focus on 0 to 5 right now. Word problems, we bring those in early. I mean, this is something you do, and think about it as a language. I mean, this is something that we want to develop with the child, and from early stages. As soon as they're introduced to numbers, these are things that we want to make sure are solid. And within our word problems, we'll be working addition and subtraction, because this is our phase 1 of our scaffold. Is that making sense so far, everyone? All right. And so in general terms, like, we have a game plan, which is just a lesson plan. So we're just kind of this, and I may probably take this out because this is more related to our general big picture math overview. It's kind of for our training for our instructors, and we use it with staff training, school staff training. So I may just take this out because it's really a little more, it's a little different from what I'm doing right now. But anyway, all right. So they're going to be in this packet, there will be printable cards. So you can print them out and you can laminate them, or you can just print them out and just cut out just the numbers or cut out just the part you need and use them as cards to manipulate and play around with. Those are going to be at the end of this packet or this group of slides. And then here's the deal. Remember we talked about imagery. Make that movie in your head. Okay, so there are blank cards and they're there for a purpose. So in this, so if you were to send this to you as a PDF and you're doing it like a slideshow with your kiddo and you're going over something that we're about to start in just a minute. We're going to start the lesson in just a minute, okay, guys? Just so you know, and thank you for hanging in there with me, and because this is valuable. This is how we do math. This is how we approach math. All this is foundational. So thank you for hanging with me. And any of you who can stay, I'm here to stay. So you just let me know. But the blank cards are in here for a reason. The blank cards are there because that's when you want to prompt your child. There's nothing on the screen. There are no manipulatives. There are no pictures of apples or cars or books or anything to count. You're wanting them to create that imagery in their mind, and not just because you had them picture 4 apples a minute ago. Take apples away. Now let's picture 4 students in a room. Okay, so that's what those blank cards are for. Okay. All right, any questions before we get into the little lesson? And the lesson is going to remember, our lesson is about this phase of our building, our scaffolding. Any questions? Okay. All right, so we can just go ahead and introduce numbers within a story, because think about cavemen and cavewomen when language came about, and eventually written language, or written symbols on the cave walls, right? Everything was around a fire in a story. So we're going to present it to our child with these symbols and their meanings within the framework of a story, okay? I'm sorry for those of you who don't like cats, but we have a cat found us in our house, so she's part of the family. So we'll just do it, I'll use my pets, and you can use that happens to be what's on here, but use your own imagination or replace it with whatever is of interest to your kiddo. But these are going to be pets, and we're going to introduce 0 to 5 and their concepts. So this just basically says what I've already talked about. You would give them the concept and have them create their own. And I'm keeping this on here, this wording, because this just says it all. It kind of has you and reminds you of why you're teaching it this way, or why you're doing these particular activities with your kid, because all this is what you're wanting to create, the language of math. All right, you ready to get started? Okay. Math story 1. Cooper's sister and the birthday cakes, okay? Cooper's sister happens to be a cat. That's Cooper. That's Kitty Claire. All right. So this is how we started off. One of something is represented with the numeral 1. Now we see 1 cake. All right. Now you could even put a blank in there, take it away, and have them picture 1 of something. Okay. What is that? Why do we have a birthday cake there? Well, and here's our number. Here's our numeral again. Okay, and what does it represent? It represents 1 of something. We happen to have a cake. You can picture 1 student in the room. Why is that student by themselves? Why is there only 1 person in line? Same thing with 2. So these are, this is just that number. And here's where we can have them, here's where you can bring in what works for your kiddo, having them draw the 2. Okay, have them use Play-Doh to put in the shape of that 2. As long as whatever they do to get that symbol in their mind, and immediate recognition of that symbol and attaching it to the concept of 2 of something, whatever you need to do to have them get that symbol, do it. Okay. We'll be creating and offering other activities to reinforce all these things that I'm saying, that are kind of can be integrated into this general framework that you'll receive via email. All right, so hopefully they're picturing 2 cakes now. And here's the deal, we're giving them these cakes, but they can also picture the kind of cakes they like. All right, but these happen to be the ones. Why are we showing these cakes? Well, again, we have a story going on. You just saw that Key Claire had 2 birthday cakes to choose from. So she gets to pick her birthday cake, and those are her choices, right? Now, here's where we're asking them to image. So all we have right now is 1 and 2. Those are the only symbols we're working with, the symbol for 1 and the symbol for 2.
Oh, yes.
Now you want to ask, can you picture 3 birthday cakes to choose from? So now you're asking your student to add to the imagery. Ask them what color their 3 cakes are. Are they all the same color? Is one strawberry, and the other one's lemon, and one's chocolate? What are your 3 cakes? I'd like to have 3 cakes to choose from. Remember we talked about with Stephen last week, personalizing it, making yourself part of the story. If you were in the story, if you're at the bakery and they said, well, pick out your top 3, you know, where would you go? Which types of cakes would you gravitate towards to get 3? Now picture those 3 cakes lined up in front of you. So there's that blank screen. Picture it, image it. Okay. Now we bring in 3. Now we want to make sure we're automatic with assigning the concept or attaching the concept to the numeral. Concept, numeral. And even that they can create their own concepts of 1 and 2 in their mind, right? They're automatic with that, they've got it, then we move on. Now we are introducing the numeral 3. And notice that because our kids deal in words as well, right? We're showing them the alphabetic or the GIF version. That's just the symbols that represent a concept. We're showing them that version of it too. And we've got our numeral that we're having them picture, have them air write it, have them have a sandbox, have them trace the number 3 in there. And they're attaching that symbol to something like this. Since our story happens to be Kitty Claire and the multiple birthday cake choices, right? You know, we'll stick with this for right now. So you're making sure that their picture of their visualizing 3 cakes looks something like this. Basically, no matter what color chocolate or how tall your cake is, or if it's a bundt cake or whatever, that there are 3 of them. That makes sense? Now, we have 3 numerals. We have 3 symbols, and we have the 3 concepts that go with each of those symbols. Let's play around with it, okay? Which is more? 3 birthday cake choices or 2? If Kitty Claire had 3 choices of birthday cakes, but John had 2 choices, which one had more choices? See, immediately we're working it into a story. Spoiled Richie had 3 cars to choose from when he turned 16. So, and then Sarah, she just got 1. Poor thing. You know, who had more choices? Who's the spoiled brat? No, I'm just kidding. All right, and then of course our blank screen so we can image all of that, which is more, you ask them the question, take all the stimulus, take any pictures away, and have them use their imagination. Okay, and again, prompting them to put themselves in the story, create their own imagery, because it's all about getting them used to, and this is something that is a skill that's not really worked necessarily in school, or necessarily, let me put it this way, and it may be that it is being worked, but they're not being explicitly and really directly told to create imagery in their mind, so to associate with a symbol, okay? So we're asking them to do that. From the very early stages of numbers, we're asking them to do that. So here, now picture in your mind having 2 hats or balls or anything else to choose from. And then now add 1 additional ball or hat or whatever to your movie in your head. Show it actually being added in. Like here you've got 2 things and here comes another. You got 2 hats to choose from, right? Oh, here comes another one. Now you've got 3 hats. So picture that movie in your head and you're asking them to do that. Blank screen. And here we even get into, and it's never too early to introduce it. Here's what this, so 3, again, we're showing them the word version, the GIF. 3 as a larger amount then 2, because it is, all right, we've talked about that, 3 choices of cakes versus 2, is numerically represented as 3, and then this, and then 2. So we verbally express it as saying, because we're teaching, I mean, that's just teaching them a little thing. It's going to exist. They're going to see it eventually. 3 is greater than 2 is what this means. That's all that means. 3 is greater than 2. All right, so back to Kitty Claire's birthday cakes. 2 cakes she had to choose from. Now picture in your mind 1 more choice being given to Kitty Claire in addition to the 2 choices she already had. Give them some time to image it. Does your picture look like this? Count them. And of course, we're not gonna do away with the whole idea of what we did with our toddlers, right? When they're little bitty and counting, oh, let's see how many little ducks we have. We have 1, 2, 3. So yeah, absolutely count them. And now we're introducing addition organically and within a story, okay? Because here we went back to where we had the symbol or the imagery for 2 cakes, and then we pictured in our brain, picture adding 1 more choice in there. Does it look like this? Yeah, well, that's our little story, and this is how it's represented. This is how we put it into language. We have 2 items, again, bringing in the word. We have 2 items, we have 2 things, 2 cakes for Kitty Claire, and then 1 more is added. So use this language. Picture, tell them to picture it in their brain or in your mind, there are 2 cakes, and then we add 1 more cake, okay? And like this information, picture this as being for you, okay? This is like how the technical term for what we're introducing, but you're telling them more in an informal way, 2 cakes, and then 1 more is added to it, right? It looks like this. Look at that. That's a little shortcut. That's how we use the number language. 2 plus 1 equals 3. We had 2 cakes. 1 more was added. That makes 3 cakes total she has to choose from. 2 plus 1 equals 3. You guys with me so far? And so this is the pattern. So I'll go through it for those of you who didn't plan on going over an hour. This is the pattern. Now, remember we talked about addition and subtraction, always done together. It's silly to separate them, okay? Same thing with multiplication and division. All right, so here, now picture in your mind 2 of the choices being taken away from the 3 because she had to make a decision. She had to narrow it down. So she had to take 2 away, okay? It's like, Kitty Claire, we cannot be at the bakery all day looking at cakes. 2 of these have to go away so that we can come up with 1 cake for your party, okay? So there's our story. Does this match your picture? So I probably should have put a blank screen in there, which I can do. I like going through these because I can always fix them. So this is what your picture looks like. Now, here's the deal. Your kiddo may have decided to get rid of that one and get rid of that one. So their 1 left would look like that. And you can absolutely express that to them, okay? So what you're checking for here is, yeah, even though Kitty Claire's choice was a little different than yours, she had to take away 2. And the thing is, that just leaves 1 cake. It could be this cake as the 1 cake that was left, or it could have been this cake that was left, but that just happened to be Kitty Claire's choice. That was the one she decided to keep. Oh, I forgot I even had it in here. Or does this match? Yeah, so does this match your picture? If you had those to choose from, does this match if 2 were taken away, does this match what you would picture? Or does this match, right? We can kind of keep it over there because that's kind of in the picture that we had them create because we're showing it to them. That cake was over there. All right. Here's where we show them, just like we did with addition. We're going to show them the reverse of it, right? Earlier we had 2 cakes plus 1 cake equals 3 cakes. So having 3 items, then 2 being taken away is represented like this. Of course, you're going to use it in language. Kitty Claire had 3 cakes. We said, my goodness, Kitty Claire, take 2 away for Pete's sake, okay? Let's choose the 2 that you like the least. This is what this looks like. 3 minus 2 equals 1, or 3 things, and then 2 things are taken away from those 3. That just leaves us with 1. Okay, so before we go on to the next slide, does anyone have any, and I'm always ready to learn. I mean, my goodness, I always find out new things when talking to people. So does anyone have any other ideas of how, either if this isn't necessarily going to work with your child, that you think maybe, or maybe you feel like you need like something that they can hold on to? And I know we're working with small numbers right now, but something that they could physically hold on to, because remember, you can always, you know, instead of cakes, you're actually using balls of Play-Doh with different colors that represent the different flavors of the cake. Any questions so far? Okay, and I'm checking my chat. All right, good, we're good to go. All right, so let's go back to our 3 cake choices. All right, can you picture them again? Ask your student first. Can you picture the 3 cakes? Okay. Does this match your picture pretty much? Okay, good deal. Now let's add 1 more cake. Now she has 4. My goodness, Kitty Claire's gonna now have 4 cakes to choose from because we added 1 more cake to the 3. And it's kind of fun to see which different kinds of cakes pop up. I like sweets. I like sweets and animals, so this worked well made sense to me. So now, does your picture look something like this? In other words, you might not have pictured that exact cake being added, or this cake may have looked a little bit different in your brain, but the important thing, do you picture 4 of them? And then count them, you know, have their finger go to each cake, 1, 2, 3, 4. Then again, continuing to show them what the word looks like with the symbol, showing the symbol by itself. What would it look like if 2 of the 4 cakes, it should be, if the 4 cakes were taken away? Picture that in your mind. That's getting a little more complex, right? But we're going to this level because we've known that all of these other things, right, were pretty solid and automatic. Even when we did activities with them, you know, it is literally looking automatic. Okay, so 2 of the 4 cakes are taken away. Again, always referring back to the whole and then its parts. So that bigger number obviously is going to be on the top. That's your big number that you're going to divide up, or you're going to take 3 of, which leaves you 2 left, etc. Okay, so making sure that they understand that 4, we've got a new big number. We've been working 1 to 3. Now we've got 4. That's a big number. And if 2 of the 4 are taken away, what are we going to have? And give them a moment to picture that. If they need to have those 4 cakes shown to them again, and they need to picture 2 of them gone, let them. You know, if they need to like put their finger over or cover up with white paper 2 of those cakes, let them see what that looks like. You have 4 cakes. Now take this blank piece of paper and cover up 2 of them. Remember, 2 of them were taken away. What do we have left? Okay, so we're working it that way as needed. And we'll talk about too what your session, because that's what you're creating. You're the teacher, you're gonna have session notes. So your session notes would indicate that with 4, when we had the prompt of 4 items and then 2 of them being taken away, since you had to go back, if you had to go back and show them the picture and all of that, that would be a prompted. So in your session notes, that's gonna have a format for you to use. Your session notes would indicate that they needed prompting to get 4 with 2 things taken away. Asking them if this what it looked like when you took 2 of those 4 cakes away, or did your cakes look different than this? Okay. And then show them the numerical value, what it looks like, how it's expressed. 4 minus 2 equals 2, or 4 with 2 taken away is 2, leaves 2. And always be using that language that they'll see, and think about word problems. I know those are like horrible things for us to think about. I know we have nightmares from grade school with word problems, but think about the type of language you would use and the type of language that they will encounter in word problems. 4 and then 2 were taken away, which is minus, leaving what? So then you know you're gonna have the difference. The difference is the answer to a subtraction problem. What was the difference? They had 4 items and 2 were taken away. What was the difference? Or they needed 4 volunteers, but they only had 2 people volunteer. What's the difference? What is the difference between what we had versus what we need? This is what we want. This is the whole. This is what we have to work with. What's the difference? There it is. Any other language that I'm missing out on, guys, as far as things that we see in word problems and how it can be associated with symbols and their representation? Because, you know, just because these numbers are little right now, because we're working foundationally and seeing it in with small numbers, this is the same phrasing and the same concepts that are going to be happening, and they're going to encounter even when they're working 17.34, even when they're working whole numbers and decimals. So if they're automatic with the language, and the language is ingrained, and the concept that goes with the language, all of that's there, everything else can build from that. Let's look at 2 of the cakes again. Okay, so here, I think you guys get the idea. Now, again, what we're doing here without telling them is we're giving them, we're not going to say we're giving them word problems. So as we're even introducing the symbols and their concepts, we're already integrating word problems. Okay. We're calling math stories. So our phrase, our way to identify this is math stories. So you're already giving them those, and you're giving them time to image it, see what they can do in their brain without needing pictures or manipulatives or any pictures of the cake or anything to hold and count. See what they can do. That's what these blank pages are for. Does this match your picture? All right, she changed her mind. She wanted to see all 4 of the cakes again. Oh, Kitty Claire. Okay, so what's that going to look like in your brain? Picture 4 cakes. It doesn't have to be the 4 she had. Just picture 4 of any cakes. Or if you want to go ahead and picture that red cake that's in our pictures, and then the one that has chocolate drizzle, absolutely go ahead and picture those. Does this match your picture? Again, they may have had different color, different flavor, but do we have 4 of them? That's the important thing. Again, bringing in a different element to the math story. And sometimes, you know, you'll have to have there are different parts of word problems you got to solve because they're multi-step. So we're already introducing these crazy, you know, these difficult concepts and these difficult skills, but we're introducing them. And so here's, you know, something else to do with that amount. Time to figure it out, blank page. Does this match your picture? All right, guys, what's going to come next? We've added some cakes, and so we want to, now, because we added to show 3 plus 1, 3 cakes plus 1 cake equals 4, and we already did that. Now let's all in the same conversation, let's show what subtraction looks like. Plus, we had it taken away. So that's what prompts us. So this wording, this problem, we have to figure out, it needs computation. It needs for us to do something with those numbers. Add, subtract, multiply, what are we going to do with them? What are we going to do with those numbers? What's the computation? Well, here's the computation. If this number were 743 and this number right here, let's say this were 743 cakes, so it's a big factory, and then 79 of them didn't turn out right, they didn't look right. You know, here's our computation. We know how we'd set up the problem. Now, are we going to do it by hand? No, we're going to just get out our calculator and put the big number. I forgot what it was now. I forgot what I said. 754, 27 of them were no good. There's how many cakes we have to offer in our factory today. And that calculator is going to do them no good unless they know what type of computation to use, what to do with those numbers, which goes in first, then this in our calculator. Okay. So when we can even start showing them this, oh yeah, we can count the cakes and show that we had 4 and one of them was taken away. We ended up with 3. And then we can also, and then we can, you know, we can do that, and then we do it in our head. We see the computation, written computation for it, and then we stick it in a calculator, and voila, 4 minus 1 equals 3. Okay, so we're going to add a chocolate cake, one that's all chocolate, to Kitty Claire's, and we'll see if we can, what kind of number we get now, because she did not have a choice where the whole cake was chocolate. So let's bring that in. What is that going to look like? Does this kind of look like what your chocolate cake that was added to the 4 we already had? Does this kind of look like it? Was yours a little different? Ask them, have them pictured in their mind. Important thing is, now we have 5. There they are. And there's that arrow. I mean, kind of, that's what I do. I always picture in my mind if something's being added, almost like little dotted lines. Like, there it is. We have this group right here and one more with that. Okay, so does this look something like it? All right, well, this is Byron, our golden doodle, mixed between a poodle and a golden retriever, and he is inside the brain. It's all golden retriever. He has the golden brain, that's for sure. He's a little ditzy. So Cooper's brother says, how about we take a break from cake for a little bit? Okay, so we've done our cake duty with Kitty Claire. Now we want to know what kinds of things you can make, you can picture. So let's just take away cakes for a bit, okay, and let's just generalize and apply those numerals and those concepts to something else, okay? So, hey, student I'm working with, picture 1 or 2 or 3 or 4 of something. Maybe you can even see 5 of them. See if you can picture 5 of those things in your brain. Blank screen. Give them a chance to picture it. All right, now Kitty Claire says enough of that silliness. Now it's back to cakes because my birthday's coming up. Now she has 5 cakes. She has 5 cakes to choose from. All right, so let's go back to that. Now count them, right? So we're just doing a review. And also in that review, introducing the numeral 5 and what it represents, okay? Now, can you, here's the numeral. Again, we saw what happened. And we see that, hey, we have a student coming in. Yes, I didn't, gosh, the time got away from me. Yes. And so, hi guys. And so here we're representing that the 1, 2, 3, 4, and we're bringing in one more, that's 5. And so they're saying it in cake version, right? And we're going to show them the numerical representation of it. And we're, again, reviewing the letters that go, the word that goes with the numeral, right? And so we have 4 + 1 = 5. And then we can talk about the language we use. We had 4 cakes. We added 1. Now we have a total of 5 cakes. So Kitty Claire now has a total of 5 cakes to choose from. Okay. And then, we introduced 0. Hey guys, quick question. How many of you, do you remember when your child was introduced to 0? Do you remember that from grade school? From their grade school? 0 the hero? Anybody? No? Okay. And the reason why I wanted to make sure that 1 through 5 was really solid is because 0 is kind of a weird concept. It's really abstract. It's nothing. 0 is nothing, right? So we want to make sure the numerals for 1 and 5 are really solid. And so now we're asking, what would it look like for Kitty Claire to have 0 cakes to choose from? Because guess what, Kitty Claire, we're tired of being at the bakery. And, I mean, what's going to happen, and how many times have you told you've either got to make a decision, or you can take away all the choices and I'm just going to choose it, right? So now picture you have 0 choices, right? So here's what 0 looks like. Here's what 0 cakes looks like. Does anyone else have any little clever things that you guys used for making 0, the concept of 0? Click. Anybody? Or do you just have any questions about something we've just done? Okay, so we're asking them, does no cakes to choose from, does 0 cakes look something like this? Number blank. No, it's just nothing. Now picture having 0, before you do that, you could even ask them, and now picture having 0 bathrooms in your house. How would that be? Would that work with your household? 0 bathrooms. Okay, so all kinds of ways to address the concept of 0. Now, so we're going to show them what that looked like. She had 5 cakes to choose from, then all 5, because they got tired of waiting at the bakery, all 5 were taken away. Poor Kitty Claire, right? She's going to have her birthday cake chosen for her. So this is what this looks like numerically. Again, we're bringing in the word to go with the numeral. We're verbalizing it, trying to use as much language as we can that will introduce them to language that's used in word problems. So have 5 items and then 5 are taken away. What does that leave you with, right? There's our difference. What's the difference between having 5 cakes and then 5 taken away? If you need 5 volunteers and you have 5, what's the difference? Oh, there's no difference, right? Because 5 is 5. If you have 5 things and then you actually have 5 volunteers, you needed 5 volunteers come, how many more do you need? 0. You don't need any more, you're done, Okay, so all of that, think about using all that language and showing them the association between addition and subtraction. Okay, all right, so there's our numeral. Now we've shown them 0, we've got the word for it, we've given them the concept, and now we're showing them the numeral. This is 0. 0. Okay, so now for those of you who can still stay around for a minute, I'm going to talk about this. We're going to bring in another way of looking at our numbers. So by this point, our student is really automatic with 0 to 5. They have a good solid association with the numeral and the concept attached to each numeral, right? 0 to 5. All right, so now we're going to talk about, so all three, Cooper, Kitty, Claire, and Byron, they want to talk about parts and wholes, right? And we've addressed that as part of the foundation, part of how we use numbers. So if Cooper says, break apart the group of 5 things you pictured in your mind. And so, of course, Cooper is going to picture 5 bones, and he's going to bury 2 of them. 2 of the 5 bones are going to be buried in the backyard next to the tree. And then the rest of them will be buried next to the fence. So here, do you see how this is comprehension right here? This is a comprehension story. Let's forget about anything else. This is just, if you were, when we teach comprehension and when we work on, it sounds weird to teach comprehension, when we work on comprehension skills, we're always giving them, we're either reading the words or they're reading the words, or we're telling them something or they're reading something, and then they're creating a movie in their mind for that piece of it. We start with smaller pieces and work into bigger ones, right? So in this small piece, in this little paragraph, let's just say, we've got a paragraph that's being read, we're gonna create a movie. So, I mean, my goodness, you know, of course, we always say the author is the boss. So you always want your author's words to be what we image. And, you know, we could picture Cooper as any type of dog, right? We just happen to have a picture of a golden retriever earlier. So in our mind, Cooper, we see this word, our image is that golden retriever, right? Again, same thing with numbers. A written representation, a symbol, and a concept. So right now our symbol is Cooper and our concept is the golden retriever. And we can go with that for now, okay? So what does it look like? What is he doing? What does it look like for him to bury a bone? Is he using his back legs? That'd be silly. Is he using the shovel? That would be even sillier. How do you picture Cooper burying bones? Okay, what color are the bones? What colors? And where is he putting it? Oh, by a fence and by a tree. Oh my goodness, a fence and a tree. That's right. What color did you picture for that tree? What color is the fence? Is it a tall fence or a short fence? Okay, that's comprehension. Now, this one just happens to have some numbers in it. So it's a math story, no big deal. So we picture, and we'll talk about how we can actually do math stories and break down word problems with what I know, what I need to know, and all that good stuff. We can go over that next time. Let's go back to our details, because this is a detail from our story. If this were a story about World War II and there was a date there, we need to have that date in our mind. It's a detail from the story that's important. So, oops. All right, so how many bones? That's a detail. All right, how many did he bury by the tree? How many did he bury by the, how many, oops, this should be, no one's corrected me. This should be 3. He buried 2 of the 5 bones in the backyard next to the tree, and the rest of them, again, all that verbiage that's used for in word problems, all that's here. And then the rest of those 5 bones were next to the fence, okay? So all that imagery we're creating, all right? Take the words away. We do this with comprehension. We read the words, they hear the words, and then we picture it, make that movie in our head. So take the words away, because we want to just focus on the imagery. Always remember, concrete, we give it to them, we give them the stimulus, so it's imaged in their brain, and we bring the stimulus back as needed. So if they forgot how many bones, like we're having them image the story, if they forgot how many bones, just like we all do when we're reading something, oh, what was that girl's name? Oh, it was Sarah, because I go back and look at my list of names of the guest. We go back and look at the passage. We go back to the words to check. Oh, okay, he had 5 bones, and then 2 of them were in the backyard. Okay, they go back to the words as needed. That's a prompt. Going back and re-looking is a prompt, so that wasn't automatic. The imagery wasn't there automatically after reading that. That's how we would create notes and do session notes and comprehension work as well. So see how this is interrelated. So all we needed was 5 numbers, 6 numbers, sorry, 6, 0 to 5. All we needed was that, and now we already have symbols and concepts and meaning with which to tell a story and with which to solve problems. Now we're already doing comprehension. That's so interrelated. Okay, great. And now this is really fun because we're going to ask them. We had them to picture it. Now we're going to ask them, does this kind of look like your picture? Like the bones that you pictured that Cooper had probably didn't have I Love Chicago on it. Long story. But you probably didn't have that, right? But did we have 5 of them? Yep, that's matching. Those are Cooper's 5 bones. Where did they go? And you know what? I think I have misrepresented this. 5 bones. Good. See, this is so great. I'm going over this. That one needs to go. And it needs to be actually here. There they are. Okay. So is this what your picture looked like? 2 of them were by a tree. Yeah. And then the other 3, because we had 3 of them, because the rest of them, 1 went here, 1 went there, the other 3 were there by the fence. And then Cooper says, don't worry if the tree that you had in your mind was smaller or bigger than the one I had in my mind. Don't worry about it. Or don't worry if your fence looks different. In fact, Byron's fence, his fence was purple. Isn't that silly? That is so silly. Byron's fence, he's a kind of a goofy dog, so his fence was purple. And so that's fine. So maybe yours look like this. The essence of the story is the same, and the author of the story didn't tell us what color to picture for the fence. So we're all good. Now picture those, and that needs to be changed, but y'all get the drift. The 2 bones here, 3 bones there. But anyway, that was the distribution, and that's fine. The numbers are matching. Well, once I fix it, the numbers are matching. All right, any questions or anything so far? You guys are so quiet. Okay, please know you can chime in anytime, and please do. Let's see. Okay, now here's another way so that we're not just doing, well, no, really this is just kind of an additional whole and its parts. And we can start that with, we don't have to wait on factor trees. We don't have to wait on that to start doing the whole and its parts. We don't have to wait until we're looking at 6 and then seeing that 3 and 2 are factors of 6 and that 1 and 1 are factors of 2 and 1 and 3 are factors of 3. We don't have to wait. We start now. There's no reason not to introduce this stuff because it's fun and it's easy and we can turn it into a story and all is good, right? It's like they're learning it, but not even knowing they're learning something. So numbers can be in families and groups like Cooper, Byron, and Kitty Claire are. So Cooper, Byron, and Kitty Claire are part of a group, right? It's their family, and it's called Cooper's family because he's the center of attention. So we can break it apart. So here's this big cloud, right? And we can take that cloud apart into its pieces, into its parts. And so here we have a mom and dad, that's 2, represented by that. Then we have his non-furry brothers and sisters. Basically, those are the children that don't have fur, right? The 5 kids. So there's 5 of them. There are 5 of them, non-furry. And then we have 1 Cooper, and then we have his furry brothers and sisters, who are Cooper, Kitty Claire and Byron. Those are Cooper's furry brothers and sisters, so 2 of them. So look at that, of his family of 10, this is how we break it apart. So 2, mom and 2, 5, 2 plus 1, all of this could be pluses, show it, put a computation, write it down, 2 plus 5 plus 2 plus 1. And you can add them in any order. You could start with Cooper, and then you could bring in non-furry brothers and sisters. So show them that, when you add it, it doesn't matter the order. When you subtract, that's a different story. So show them that. And so here we have it broken into parts. All of that equals 10. Okay, and so here, show them that same family can be broken up into parts, and the parts can all be different. As long as that number is the same up here, the parts can still be different. So here's Cooper's family, and now he wants to divide them into furry members and non-furry members. So here we have non-furry members. There are 7 of them. And then furry members, that would be Cooper, Kitty Claire, and Byron. There are 3 of them. And see? It's just different parts with the big number at the top. think of it, I always think of it like a triangle or a triangular cloud. Big number here, parts down here. And what this looks like. Remember, we've already introduced to them, so I know these are higher numbers, it's okay, but we've already introduced the idea of computation, of addition, and use that language. If he has 10 total members of his family and 7 of them are non-furry, how many are furry? Turn that into subtraction. That becomes 10 minus 7 equals 3. Again, showing how, how we can break apart further. So we've got Cooper's family. We've got furry members and non-furry members. Of his furry members, how many are cats and how many are dogs? Well, we've got 2 dogs, 1 cat. That makes a total of 3. And the 7 non-furry members and the 3 furry members gives us a total of 10. So all of these numbers, these 2 numbers make up this number. So these 2 parts make up this whole. Of this particular part, it can be further broken down into smaller parts, big, medium, small, smaller parts. And then showing what that looks like in math. 2 plus 1 equals 3, because that's how many that's how many furry members are there. Or in Cooper's family, that big number. That's how we got the 3. And it works for cakes too. So we're showing them different ways of looking at it and how it can all be expressed in different ways. And we can draw pictures of it in different ways. So let's go back to Kitty Claire, the 5 birthday cakes. There they are. And she had 2 that have chocolate on it. That has some chocolate drizzles. That's all chocolate, so there are 2. And then no chocolate, boom, boom, boom. There's a 3. Okay, any questions before we look at a couple of activities? Okie dokie. So how do we work these? So these are the skills that we want them to have. Remember our objective. Automaticity, independently recognizing and attaching concepts to numbers 0 to 5. Okay, that was our goal. Great, and we presented it. So we presented it this way, looked at it in various formats, right? Uh-oh, let me go back to that. Uh-oh, just lost my thing. Sorry about that. There we go. So we've looked at it and approached it. We've organically introduced these concepts. I mean, these are a lot of concepts we're introducing, and all we're doing is 0 to 5, right? These are a lot of concepts and a lot of language we're using. So, you want to keep your language appropriate for what your kiddo can handle at one time. Keep it simple, but introduce larger, bigger words or synonyms, more higher level synonyms. So instead of different, you would say equals, 2 minus 2 equals 0, or what's the difference between 2 and 2? So that's a higher level, but if the foundation is there, you can always add the vocabulary, increase the vocabulary level. That's, just like with comprehension. All right, so any questions before, let me ask again, any questions before we get into some practice? Because so we've introduced the concepts, we've worked with them, we've done stories, remember you can do things like writing the numerals in sand and making sure that if they draw a 2 in the sand, that they can attach that to 2 items in their mind, that they can picture 2 things in their mind. Okay, sorry, I'm trying to find our activities. All right, so math story 1, which is Kitty Claire and the cakes, and Cooper's family. So we're going to match the symbols with its concept from the story. And as I told you earlier, we have notes, some pages where you can write your session notes, and you can just, make copies of them as needed. Making sure that your kiddo is accurate and automatic with the activity. And so that once you reach 90% or more accuracy and automaticity, quick and accurate, once that's reached 3 times in a row, go on to the next activity. And then when you get this packet, you may come up with some of your own activities, and please share. So when we come back together, Thursday, hopefully you'll come back. Hopefully I haven't I really want you guys to talk more. Hopefully I haven't been talking too much, but when we come back Thursday, try some of these and let us know give us some ideas, because when we collaborate, that's how we, because if you're working on your child, there might be some similarity. There will be. Somebody will say, oh my gosh, my child tends to learn that way. I'll try that next time. So we'll regroup. So these are the notes for your kiddo, and this will make sense in a second when I show you the activity, but here's where you will record if, for example, just sneak peek here, we're going to attach the numeral. Well, I think I already had it here. We're going to attach the symbol, the numeral symbol with its concepts. So here is the numeral, and you'll record here their ability to automatically connect the symbol, the numeral, to the concept, and were they automatic? Did they self-correct? Okay, let's say that would be 3. Oh, wait, no, that would actually be 2. Yes, got it, yeah, great. We love self-corrections. Self-corrections are even better than getting something correct. Sometimes you can by accident get something correct, but when you self-correct, it means that you had one approach and you had one plan and then you revisited it. And we use this all the time in fluency and comprehension. Self-corrections are huge because that means they're self-monitoring. And we always use our error handling, something else we talk about with fluency and comprehension. The way we handle errors is a strategy to help them get to the point where they're self-monitoring and self-correcting. So self-corrections are great. Indicate that, and if they flat out missed it, indicate that, okay? So here's the activity. I even gave you a couple of versions of it. Okay, so here's the activity, here are the numerals, okay? Here are the concept cards to match. So they're gonna match the number of cakes with the numeral. So there are concepts. Then you can take away the cards and have them show you with some dominoes. Okay, so now show me, or something that doesn't have dots, anything. Show me with these little cutout circles how many match. Find me or gather the little circles, the little pegs or whatever, that match this numeral. Record how automatic it was. And those are your session notes. And you can come up with if they got 5 out of, if they got 1, 2, 3, 4, 5, 6, and they did it 3 times, and each time they got 4 out of 5 or 6 out of 6, and then they missed one time, that was 5 out of 6, then they got another 6 out of 6. That's 90%. They've got it, and you're ready to move on to the next activity. Any questions about session notes, accuracy, and when to move on to the next activity, or anything else? Okay. All right, so here's just a different version of that same activity where they have to actually find the card with the number of cakes that matches the numeral. And this one needs a 0. Yeah. Now it has one. I created this. This is like I've compiled this from a bunch of our other math stuff to kind of. And so some of this I haven't had time to check over. And so now we're bringing in adding and subtraction. They don't have to know that. We're keeping it still within a story. We don't have to announce, now we're going to work on addition. No, we work it into the story that we've already created, and we keep that same organic thing going. So this time we're going to match the symbol expressions, and those the addition and subtraction computation. We're going to match it with an image. And again, we're going to use our notes to track accuracy and automaticity. Once they reach 90%, 3 times in a row, we move on to the next activity. What does the activity look like? Well, there's our score sheet, or our session note sheets. Those are our session notes. Make sure to put the date too, because if you work on this in 2 separate days, so you can show progress. So if they got 1, 2, 3, well, actually, these are all a continuation. But if they got 8 out of 10 on Thursday, and then on Friday they got 9 out of 10, well, that's progress. That's awesome. Those are our session notes. All right, so here's the activity. So here's the numerical expression. Here's 1 + 1 = 2. They're going to need to find, of these choices, they're going to need to find the one that represents, and these are in order. You're going to put them out of order, of course, right, guys? So 1 + 1 = 2, but the numerical expression that matches that would look something like this. Kitty Claire had 1 cake, and then they added another cake to her choices, and then she ended up having 2 choices. Not making sense? Okay, so these are all, so those are the expressions. And then as you see, we're not shying away from subtraction just because we were just introduced to the concepts and the symbols of 0 to 5. We're bringing it in, okay? And so we may stay in this area, this activity for a while. I may need to do this activity several times. And again, feel free to add things other than just pictures of cakes into because I think you're getting the concepts now that we're working on, and you can work on it with different stimuli, and different manipulatives. So see here how we went ahead and brought in subtraction, because it's just, this is all a family. Our big number is 3, that's our whole. It just happens to be in the end here. We happen to take the parts and make a whole. There, we did it. Okay, so there's our whole, the biggest number, there's its parts. Same thing here in reverse, same thing, same whole. Here, this time our W-H-O-L-E, whole, is the whole. I mean, is the first number. We're gonna start with the whole. Then we're gonna take a part away. We're gonna take a part of that whole. We're gonna take it away. What's left? All right, and then they're gonna match it with the concepts. And then the concepts look something like this: a 3 minus 3 cake choices minus 1 cake choice equals 2 cake choices. All right, and the next activity. So yes, this works all the combinations, and then all of these combinations are represented in the session notes, right? So you can make 3 copies of this and work this activity 3 times or more. Then you can write down there, automatic, and if it's automatic, it means it's correct, right? Automatic and correct, accurate. They had to self-correct, or they missed it. So that's how you track their progress. Okay. And then our next, any questions before we go into the next activity? So with 0, we're working 0 plus 0. There are no cakes in our picture. No cakes in our picture. How many cakes do we end up with if we add nothing and nothing? We get nothing. So, weird concepts, but we're working it nonetheless. If you have 0 cakes to choose from, and then all of a sudden 1 cake was added to your choice, how many cakes total do you have? 1. 0 plus 1 is 1. Okay. Now, our next activity is still within the framework of adding and subtracting. We're going to match the symbol. So as you see, we're going from symbols and concepts with the pictures to represent the concepts, okay, to now we're just going from symbol to symbol. We do the same thing with, we'll talk about it more, but with fluency and comprehension. So symbol, and now we need to find the symbol that completes our symbol expression, right? So you can go back and use those same number cards that we had 0 to 5, ones that we had from activities 1 and 2. And then you can use the, again, use the notes. Here are the notes. So we're working the expressions, the computation. Okay. All right, so this time we don't have the answer, in other words, okay? This time we have the symbol expression, and we just need an answer. Here we need a total. Here we need the difference. So there are those, and then the ones to choose from would be the number by itself. I'm sorry, yeah, we had, the answer is always going to either be 0 or 5, so you can go back and grab the 0 to 5 from the previous activity. Again, this activity 4, involves adding and subtraction as well. Now you're going to find the symbol expression that matches the story, matches the math story problem. With this one, we're going to have the computation, like symbol expression. In other words, 2 plus 2 equals 4. Okay, we have the computation, but we're going to have it, we want it to match the math story. So in other words, you're matching the word problem in the way we think about it. We're matching the word problem with how you would solve it. So we're not even worried about the answer here. And so you can either give them the symbol expressions that already have the answer, or you can give them the ones that don't have the answer and have them supply it. your call. Okay, so here again, we're matching the math problem or the computation to the story, to the math story. Okay, so here, several math stories. I have 6 math stories to choose from. And guys, you'll get the hang of this and you'll come up with your own. Okay, you'll come up with your own math stories. Here's the first example, but again, there are some other ones. All that choosing made Kitty Claire hungry. She was looking at 3 cakes and ate one of them. How many of the cakes she was looking at are left? Okay, so those, and then we can go in next time about how we work word problems, the process we use to work word problems, what we pull from the problem, and we make a little chart. I can show you that if someone will remind me. It's called What I Know and What I Don't Know, Wick and Wink. So here's our story problem. Which one of these would match? Go up and find what are you gonna do? How are you gonna solve that? Okay, and then the last activity, because this is even more abstract or kind of, and it's more of like a skill that they're going to need to have as they start to work with numbers more, is they're going to match the numeric symbol with the words. So the glyph, and I think I said GIF earlier, it's glyph, matching the glyph with the symbol. All right, as always, you've got your notes, your session notes. And so you'll pull from those numbers from the previous activities where the number was all by itself, the numeral, and then here are the words. Oh, I'm sorry, here was another activity. Activity 6, you're matching the symbols with the words again. And this time we're going to use number clouds. So we're going to make it rain numbers, and we're going to have clouds that represent the whole and its parts, okay? And I just put a few in here, and you can kind of get the gist of what's going on. I've given you session note format. Here's the examples. So Kitty Claire had 5 cakes, 2 had chocolate, 3 had no chocolate, and making sure that these 2 numbers add up to this. And here's the great thing, and we'll talk about this more with multiplication and division. We use, for multiplication and division, we use triangles, but for addition and subtraction, we're going to use clouds. So if we can also use this chart here to figure out if you have 5 total things and 3 were taken away, what remains, or what's the difference between 5 and 3. With the next slides, we'll start introducing the number line and place value with the next packet. So if you're on a number line and you are at 3, you're at 3, but you want to get to 5, what's the difference? In other words, how many steps are you going to have to take on the number line to get to 5? It's going to be 2. Okay, parts and whole. Here, and you can have fun. I've provided you some blank ones. So you can have fun with this. So here we go back to the previous story, and it was, yeah, see, I've got it right here. No, it was actually supposed to be 2. I'm gonna go ahead and fix that now. I think you buried 2 by the tree. Does anyone remember? I'm gonna check your imagery, and this will be fun. Next time, in 2 days when we meet, we're gonna practice these on each other. And also want to get some feedback on how it worked with your kiddos. Does anyone recall, was it 2? What was the official story? Did he bury 2 bones by the tree or 3?
2 by the tree and 3 by the fence.
Thank you, ma'am, Miss Tanya. Thank you, ma'am. Yep, 2 by the tree. All right, so I fixed that one. So now we know what's by the fence. Thank you, Miss Tanya. All right, and here, oh, yeah, another one, so we'll go back to our cakes. She had 5 total, right? Well, if one of them has green flowers on it, how many do not? And here we've got, they can count them, so 4 do not have green. That has some yellow green right there, and here's your blanks, so they can make their own, and you can make your own for them. You can either supply the top and one of the bottoms, and they have to do, or you can provide the whole, you can, and one of the parts, they have to supply the other part, or you could give them the parts. This could be 17 cards. No, we're not going to hit that number. We're going to stick with this, but you see how you could absolutely use this when you get into bigger numbers. 27 chores to do. Here is part of those chores. You've only done 7 of them. How many more do you have to do? A bunch. Okay. So you can break this up and utilize this concept. This is really building towards how we use, product trees and all that. So this is a good pattern for them to get used to, because we'll use it with multiplication and division. So our whole and its parts. So you can have some fun with that. Now, we had a story, have them tell their own story. Have them make a cloud and use the number that that they have automaticity with. This can apply to once we start getting into 10, 15, 20. This can apply. So get them used to this pattern of how to picture the parts and the whole that they make up, okay? And then they can make a story that goes with it. And they can tell their math story. Because remember, when we talked about with comprehension, it's not just creating the imagery and organizing it nicely. It's being able to give verbal expression, and which comes before. Writing can't come before verbal. You got to be able to express it clearly and coherently and completely, keeping all the important details in there. You have to have it here, and then you can verbalize it, and then you can write. Okay, that's the way we work it in comprehension. So it's not just good enough just to have that story in your brain. What's good if it's all up here? You need to be able to share it clearly with other people. So have them tell about their math story that they created on their clouds. All right. Oh, and there we are. My goodness. So thank you for hanging in there. I did not plan on going this long, but it's so much fun. And to me, this really is the foundation. By going through this, it really shows, number one, how we approach math and build math skills, and how math is a language and we treat it like we do fluency and comprehension. It's all so interrelated. It's all so related. Okay, so I'm going to stop sharing, and you guys tell me what you think. What questions do you have? Okay, someone said it was helpful. I did not ask them to say that.
Very helpful.
Okay, great. Please do this. Send me, I'm going to write my email here. Oops. I'm writing it in the chat box. Does everyone see the chat box? But I'll say it as I write it so you can jot it down. It's Denise, D-E-N-I-S-E, then the letter H, Denise H, at DH dash, you know that little line like a minus sign, DH-READ.com, read. So it's Denise H at DH-read.com. So if you send me your email, I can send you this packet, but I'll make the corrections, the boo-boos that I found in it as we were going through it, which was really awesome. So thank you for bearing with me and with going through all of that, because it's so important. It sets the foundation of how we approach math, and it shows how math is a language and we treat it like we do fluency and comprehension. And it's building a skill in one helps with the skills in the others. Okay, so send me, so email me so that I can have your email. And let's see. Yeah. Oh, sorry. Thought I had sent it. Let me see. Did I hit return? Okay, everyone. Sorry, I meant to see why it's not. Hold on. I don't know why. Everyone. Now. Okay, there it is. Sorry about that, guys. Thank y'all. Yes, Denise H at dh-read.com. You're welcome, Jenna. So yeah, so email me and I'll have your email, and I will send you this packet after I've made corrections, and play around with it. Let's meet again on Thursday and see how it went. And maybe we'll get some brave teachers out there who can show me how they use this and approach it. Remember to always use imagery language. Treat this as a story, because it is. Math is the means of communication to share information. Anybody want to unmute and say anything? I mean, any questions, comments? All right. You guys, thank y'all. Thank y'all so much. See you Thursday.
Same time?
Same time, same place for math, yes.
Okay.
All right. Thanks, guys. Bye-bye.
Hey, Denise, where will the code be given? Is
Where-
Joe going to give the code, the Zoom code, or we use the same one?
Use the same one, yes. But the James has on his link, has the links to all 3 of the different breakout rooms,
Okay.
including mine. So those links are the same. And so the room numbers are all the same for now, unless we have to subdivide more, whatever. We'll go with this for now.
Okay.
Okay. All right. Bye, everybody.
Bye.
Bye.